Good morning, everyone. Thank you so much for coming, and thank you for having me here at GOTO Amsterdam. I'm very, very happy to be here. My name is Ray. I'm a developer advocate for the Google Cloud Platform. And there are two things that I do that I enjoy doing. Number one is I love to bring some of the latest and greatest technology from Google that we have to offer to developers all around the world. And the second thing I love to do is to hear about your experiences and your feedback about the session today, about the technology I'm going to show you today, and also about Google Cloud Platform as well. And the best way to reach me is on Twitter at @Saturdays. That is my Twitter handle. So if you have any questions, please feel free to reach out from there. And aside from technology, I've been in technology for a very long time, 15+ years or so. And prior to Google, I was working at an open source company. Prior to that, I was at a consulting company. But my other true passion of mine is actually traveling. I love to travel, and I love to take photographs as well. And if you'd like to see some of the photos and places I've been to, feel free to check out my Flickr at flickr.com/Saturdays as well. If you have any question about this photo, especially where I'm holding a compass in the middle of the desert, I don't have the time to talk about it today, unfortunately. But I think my sound just went away. There we go. But if you have time, just come up and ask me about this story, and it's quite interesting. So I'm here to talk about microservices today, and I'm assuming that many of you already heard about microservices, right? How many people here knows about microservices? Yeah, I know. Yeah. So I'm not here to talk about the theories behind it. I'm not here to convince you one way or the other of what you should be doing. But if you do want to explore and create microservices architecture, here are a few things I like to share, and this is going to be mostly the how-to and the experiences that we are happy to share with everyone. The first problem that you're going to run into is that as you're decomposing or as you're creating a new application, new system with microservices, the first problem you're going to run into is there are going to be so many services. If you decompose a simple application into, say, these two services, you have the front end, you have like multiple backends, say 2 backends, and that's already 3 instances of your application you have to deploy and manage, rather than just one. And of course, for redundancy reasons, you probably have multiple instances of each of those services as well. And now you're looking at potentially a multiplication problem. You have 3 different services you have to deploy, 2 each, that's 6 that you have to manage. But 2 is probably not enough. You might scale some of these layers out more than the other. And eventually you're going to see maybe 30, 40, 100 instances that you all have to deploy and manage. And that will be fun. And the traditional way of managing these services just don't work anymore. Why? Well, typically what's going to happen is that before your project even starts, maybe even now, you have to request the servers to be procured. Right? I don't know if that happened to you, but when I was doing my project as a consultant, I have to order the number of servers even before the project starts, maybe 9 months before the project finishes. And then the servers will come in, and what I have to do is do what? I have to write like a little documentation that's very, very long on how you are able to install the servers and put the right components onto them, and then finally deploy your application. So like the operating system, the utilities you have to install, how you want to configure the hosting, the network, the firewall, and then you probably lay down, like if you're using Java application, you lay down the application server, like Tomcat or WebLogic, whatever, and then you configure it, and then finally you deploy your application onto it. And then very quickly you're going to find out, like me, that your deployment probably doesn't work the very first time. How many people have that happen to them before? Yeah, I thought so. And the other problem you're going to find out is that in the production environment, you are going to run into the trouble where it just doesn't work, and it works everywhere else outside of production. Right? How many people have that happen to them as well? Yeah, it happens all the time. And the problem with that is that usually that this long and complicated procedure is either done through manually, where somebody actually follows it to create an environment, and it's not very consistent. And if you script it, also you have to write that script, and if you make any mistake in that script, then you are also going to run into troubles. And those scripts may even run differently from environment to environment. So one of the first things that we need to solve is how do you actually deploy the same application multiple times in a scalable fashion. And one of the first thing that you need to look into, of course, is the containers. How many people here know about Docker containers? Oh, everyone, yay, all right, so I'm not going to go into those in detail, but just remember that, hello, hi. Just remember that if you're using containers, you're documenting the installation procedures in a sequential order. I'm just checking if there's another sound, yeah. And that is still documenting in terms of what you want to run. And that image can be deployed anywhere else. And you can very quickly stand up new application instances very, very quickly. The other problem you're going to see is that if you have so many services, you don't want to put all of them individually, one on a single machine, right? Because if you have 100 servers, you don't want to have 100 machines. So what you need to do is to bin pack them as efficiently as possible into a single or the fewest machine possible, so that you have less infrastructure to manage. And when you do that, then you're going to run into issues where potentially you may have multiple instances on the same machine. The first thing you're going to run into is the port conflicts, and you want to avoid those as much as possible. And then you have other challenges as well. How do you make sure that they're all up and running? There are so many to monitor. How do you do that? You cannot do that manually, of course. You need to be able to check the health of these systems and individual services so that when they have issues, maybe you need to restart them. And again, you don't want to do this manually. You might want to do this automatically as well. And one of the biggest challenges that I see, and many people ask me, is about environments. If you have, say, 30, 20 services in your environment that you have to run and manage, how do you create more of these environments and reproduce them in a consistent fashion? Remember, deploying one application is hard enough when you don't have the right tooling to do so. You'll raise your hand. Now you're going to be dealing with hundreds of them, and you have to think about the tools that you're going to use. So today is all about the tools I'm going to share. Okay. And many of the .coms, the technology company, have the tools to do this, including Google, of course. And I think it's partially what makes microservices architecture successful. If you actually go into this architecture without the right tooling, you may actually eventually find yourself in a situation that you just simply cannot manage any of these at scale. So at Google, just remember this, everything at Google, all of the services that we offer, including search, YouTube, Gmail, I'm assuming everyone here uses some of these things, they all run in containers within Google. And we're not using Docker containers, but we're using the fundamental container technology. In fact, Google contributed the fundamental technology that makes container possible, which is called C groups. So we contributed C groups into the Linux kernel many, many years ago. And that is the fundamental technology that all of the new container formats are kind of using today. At Google, we launched about 2 billion containers per week. Now, this number is not as impressive as it sounds. Why? Because this is the US billion. It's not the European billion. I know there's a very big difference between, yeah, I know. It's not 2 million, it's only 2,000 million. It's not, yeah, there's an order of magnitude difference here, but we know how to manage containers. We know how to manage our services at scale. This is what we do at Google. As an engineer, we cannot possibly deploy the application the traditional way that I just described. This is what we do. If I have a hello service, hello application, a very easy one, the only one I can write, rather than deploying it into individual machines ourselves or with a script of some sort specifically designed for those machines, we deploy to a target of a cell. A cell is really just a cluster of machines, and a single cluster of machines at Google, a single cell, can be composed of up to 10,000 machines. Okay? So we don't deal with each machine individually because that would just be too many. But what we do is we run tools to do this for me. We just say how many here's the cluster I need to deploy to. Go figure it out for me. We specify the binary that we want to deploy. These are potentially static binaries that can just be copied and deployed on any of the servers. We can specify arguments, but most importantly, we are able to specify the resource requirements. And this is where containerization is going to be really helpful because we're running multiple services, multiple applications. You don't want them to step over each other's toes when they are fighting and competing for resources, right? You don't want one runaway service to take 100% of the CPU and like all of the other applications just don't work anymore. So with resource isolation, you're able to contain them so that they don't exceed their boundaries. And then we can say how many instances of this service do we want to run. we can say, I need 5 replicas, that means 5 instances. Or at Google, maybe we need a little bit more. And it's super popular because that's the only thing I can write. We want 10,000 instances. We just say 10,000. And this is so decorative. You just say how many you want. You say what you want to deploy. And we deploy it. And this is the way it works behind the scenes. We will copy the binary into a central repository of some sort, like a shared file system, where all the machines can get to. Okay? And then we're going to send that configuration file into our internal tool. The internal tool is called Borg. And there is a master node, which is called the Borg master. And the Borg master understands how to receive the YAML file or the configuration file and knows how to deploy it. Once the Borg master receives it, it's going to consult the scheduler, which then will be asking all the machines the same question. Do you have enough resources to run this application? And it's going to check all of the available server nodes to see who's available to run this application. If you cannot run it, it will just skip you. If you can, then what it's going to tell you to do is to go ahead and download that image and then start it. Okay? And we can do this very, very quickly. And very quickly, you're going to see my Hello World application running in the Google Data Center simply by deploying this one descriptor. And we can do this so fast that we can deploy about 10,000 instances in about 2 minutes and 30 seconds. And that's partially because we also have very, very fast internal network that we can actually copy these large images around very efficiently. And you do get that kind of benefits if you're using the Google Cloud Platform as well. So that's how we do things within Google. But that's not enough, right? Because that's all internal. If you want to try this out yourself, well, this is what you need to do. This is where that Kubernetes is coming, right? Kubernetes is the open source project that is designed to orchestrate containers. So if you're running your applications inside of containers, and if you need to deploy it at scale, then you can use Kubernetes to orchestrate them across multiple machines, just like in the similar fashion that we do within Google as well. And Kubernetes is actually based on the experiences and the scale that Google had for the past many, many years, and deploying so many containers. We know how to do this at scale. We know how to deal with the common issues. So then we actually open source this Kubernetes project. It's all open source. It's written in Go. The important takeaway on this slide is that it will run in many different environments, in multiple clouds, and also on-prem. And that's super important as we go into the demo in a few minutes. The community is very, very vibrant. We're on version 1.2. I think 1.3 is coming out very soon. We have many, many contributors and many commits and many stars. Well, basically, the gist is, if you want to try it out, please get involved with the community as well. They have a Slack channel. They have a forum. They're very responsive on GitHub as well. So please go check it out if you like to contribute or learn more about Kubernetes in detail also. But today, I'm going to just give you a taste of it. So this is how it works. It's a very easy slide for me to make. If you haven't noticed, all I have to do is copy and paste the previous one, and do a string replace. Yay. So this is how it works. Rather than a static binary, we are building a container image, which is inherently a static binary anyways. And it's a Docker image. And I can actually push this image to a central repository. And in the Docker world, this could be known as a Docker registry. Right? You can have a registry online. You can have a public one or a private one. You can store it wherever you want, as long as the machine can get to it. Then you're going to be able to write like a similar configuration file that says what you want to deploy. You push it to the master checks against the scheduler, and then it checks with all the machines in the cluster and say if you have enough resources to do it, to run the application, and then it's going to pull down the container image and start it. Easy, right? It's very simple concept, but it's very powerful because first of all, it allows you to describe what you want to deploy in a simple file. Just like that, you can specify the resource limits as well. But you can also specify how many instances of something you want, very similar to what we do internally. But here's the catch, or the most important thing that you want to remember. With Kubernetes, you're really you're viewing your entire cluster as a single machine in a way. All the resources on individual machines, all those CPUs and memories that's available to you, you manage them through a single pane of view through Kubernetes. They're just one Kubernetes cluster to you. You deploy it to this one single Kubernetes cluster, and we'll take care of how to put it on the actual machine for you behind the scenes. So enough of the talks. I'm just going to go into the demo very quickly. Not that one. So I just want to show a hand. How many people here are Java developers? Oh, I'm in the right place. OK, fantastic. So you probably already know how to containerize your Java applications. You either use the Docker file to do it, or I just want to point out one thing, which is there are some really, really nice plugins you can actually use if you haven't used them already. Let me see here. So Spotify actually produced a couple of plugins for containerizing Java applications with Maven. They have two. There is a Docker Maven plugin, and there is a Docker file Maven plugin. Now, don't ask why there are two. It's a better question for them. But actually, I know why. But they are both very good, and they do things a little bit differently. But the beauty here is that you can actually capture your Docker image creation process inside of your pom.xml. And the beauty of this is you can actually tie this into the execution phases, so that whenever you're packaging your jar files, you can also produce the container image at the same time. This is really useful. And then you can also tag it with the version numbers of your Java application too. Or if you want, you can also tag it with your Git hash also. So let me go back to this service right here. And now, another question is, how many people here heard about Kubernetes before? All right. Well, before I talk about it, obviously. All right. But sorry. But how many people here has used it? Oh, well, I'm glad you're here. So how many people here have seen in action? Seen it? Oh, quite a few. OK, so many of you haven't seen this, so this is going to be new. OK, so first of all, what I'm going to do, what I have done already, is that I created this image, and I push it into a registry. And now I have this image in the registry somewhere. I just want to run this at scale on many different machines. And the way I can do that is not delete, kubectl run. So I don't know if you can see this on the top. Yes, you can, hopefully. So to run the image, a container image, in a cluster of machines, it's very easy with Kubernetes. Here I have a cluster of machines in the Google Cloud Platform. I have 4 different nodes that can actually run my workload or my applications. All I have to do is to say kubectl run. You can name this however you want. I'm just going to code this hello world service. And then I can specify the image. This is the image that I want to deploy. And this can be located anywhere that the machines can get to. And I'm using a private Docker registry that comes within the Google Cloud Platform itself, so that I just push my image there, and I can download it from my projects in Google Cloud. And then here's the important part, the -L. Following that, I can specify a bunch of key value pairs. And this is very important because these key value pairs are labels. And that's a very important concept in Kubernetes, because everything in Kubernetes can be labeled. And the label, the key and the value pairs, you can name it however you want. For example, if you like, you can say, I want to label this deployment version is 1.0. I can say that this is the environment of staging, maybe. I can also say that this is for the conference, GOTO Amsterdam, right? I can name this however I want. The important takeaway here is that with labels, in the future, you can query Kubernetes and say, please tell me all of the applications who has the label of app is equal to hello world service and of the version is equal to 1. You can query this later via the API, and it's also very important when you want to route the traffic to these application instances. OK, so that's what I have to do. I'm just going to run this command line to start a service in my cloud, in my Kubernetes cluster. And as you can see very quickly, it just got deployed. And I haven't done any manual scripting here. I haven't done anything else to say which machine to deploy to. I got 4 different nodes here, and I can see that this got deployed to one of the nodes, TPLA. The 2 boxes here are very, very important. The box in gray is what we call a pod, P-O-D. A pod is the atomic unit that Kubernetes can actually manage. Now, you may be asking, hold on a second. I thought we were all talking about containers here. I thought containers are the atomic unit that we should be managing. But in Kubernetes, it's called a pod. Now, what is a pod? A pod can be composed of a single container or multiple containers. Okay? And they are guaranteed to have the same IP address. A pod has a unique IP address. They are guaranteed to live and die together. So when the pod dies, all the containers within the pod will go away. And they are guaranteed to be scheduled onto the same physical machine. Now, what would you actually run within the same pod of the different containers? If you have an application with the front end and the back end, Are they tightly coupled together that you want to run inside the same pod? The answer is actually, no, you probably don't want to do that. Why? Because if you do that, you cannot scale the front end and the back end independently from each other. Okay, so you want them to run in separate pods in this case. So what would be a good use case for the pod? Well, maybe you have a Java application that's exposing metrics via GMX. And your system has another collector that needs to collect the metrics with a different format. Well, rather than writing and changing your application to talk to that format, what you can do is to run a sidecar container in the same pod that's able to understand GMX metrics and also being able to push it to the metric server the way that the metric server understands. So you can actually compose your application with multiple tightly coupled components if you want to. Now, the box in blue, that is called, we call this a deployment. And it does a few things for you. And very importantly is that you can tell the deployment to, well, first of all, deploy the application. When I was running this, I was actually deploying the copies of the pods. What you can also do is to scale. You can say kubectl scale the deployment hello world service. And how many do we want? We can just say replicas is equal to. And then I can say 4. And it's going to tell the deployment that I need 4 instances now. Deployment is going to say, check against something else. It's called the replica set to say, hey, do I have 4 instances now? Do I have 4 replicas? If I don't, then I need to spin up more. If I do, then I can stop. If any one of these instances goes away, it will actually notice it and say, oh, no, I have 3, but I need 4. Let me go ahead and start another one for you. So that's very easy to do. And we're going to see deployment in more detail in a second. Now, notice that every pod here, every box in gray, has a unique IP address. Now, these IP addresses are unique to the pod. They can talk to each other even if they're not on the same machine. But they come and go. They are ephemeral. Then the question is, how do you actually get to these services? How do you actually consume it? If you need to know all the IP addresses, that's probably not the best way to do it. Typically, what you do today in your infrastructure is you create a load balancer in front of this, right? And then you configure the load balancer to know which are the backend endpoints. In Kubernetes, well, these backend endpoints can come and go. The IP addresses could change. So you don't want to configure those manually. But in Kubernetes, we have the first-class concept, which is called a service. Okay? And a service is really almost like a load balancer. Once you provision it, it will give you this stable IP address that will then be able to load balance your request. So to expose all of these pods as a service, all I have to do is do kubectl expose. Oh, sorry. Expose, there we go. kubectl expose the deployment, which is the box in the blue. And I can say the port number, 8080. That's what the external port I want to expose at. And then the target port is 8080, because that's where my application is running on. So I can expose this application by putting a load balancer in the front, and that is the box in green. And the way that the service decides where to route the traffic to is by using labels. So if the traffic request comes into this green box in the service, it's going to see, well, which one of the gray boxes, which one of the pods matches my label descriptor that says, well, it has to route to the application that's called Hello World service. And now I can actually get to this service. Now, another very big question that you're going to run into is how do you discover your services? If you have multiple of these things, how do you actually know the IP address that you need to connect to? Well, many people actually run a separate registry of some sort. Well, Kubernetes actually have this right out of the box as well. So there are multiple ways to do this. The first way is potentially using the API. So I can access everything that I do from the command line. They all make API requests behind the scenes. So even to know which services are actually available, I can use the API. I can actually get back either llamo or JSON payload, and I can see all of the services that's running here. So if I go and look for Hello World service, I can have all the details about it, and I can also get its IP address, right? But you don't want to do this every single time. Kubernetes actually exposed the service as a DNS host entry for you right out of the box. Yeah, that's really nice. So for example, let me just do one more thing here. If I were to get inside of the cluster, and the way I'm going to do it is by running a bash script directly inside of the Kubernetes cluster, and I'm going to do a kubectl exec.ti, the name of the container, and bash bin. And if I have internet, this will connect. There we go. It's really slow. Get off. Stop watching YouTube videos, please. Yeah. So I'm inside the Kubernetes cluster right now. And what I'm going to do is I can curl this URL, of course, I can do the IP address, 8080, hello, Ray. And that worked. Whew, that was a little slow. But like I said, you don't want to do this all the time with the IP address. And like I said, we actually expose the DNS name. So this becomes very, very easy to do. So I can say, hello, world service. And there we go. It just resolves it right behind the scene for you. So you don't really have to run a separate registry anymore if you don't want to. When the instances come and go, they will actually update the endpoints behind the scenes, and it will always route to the right and available instances. Now, if you really want to know what endpoints is behind the scenes for this particular service, what I can do is that this is called Hello World Service. I can actually do a kubectl get endpoints in the name of the service, and I can actually see a list of endpoints that's available and ready to serve. So if you don't want to do a server-side load balancing, if you want to do a client-side load balancing, you can still get to these IP addresses also. Yeah, that's all good. It's pretty easy, right? It's very easy to do. But what I have just done is really just deploy a stateless service. And of course, your application probably have state. And so to show you a little bit more of how to deploy a full stack application with state, I'd like to invite my co-speaker, Arjen Wassink, to the stage.
Well, thanks. Yeah. Is the mic on, or?
Oh, yeah, where's the mic?
Yes, the mic, yeah.
Oh.
Yeah. Okay, then I'll do it without mic. I'm Arjen Wassink, I'm an architect at Quintor. Quintor is a company specialized in development and everything that comes with it, and that's quite a lot at the current time. So one of the things is that we see is that the kind of applications we were building some years ago were quite big. And now we are having more and more instances of the software we need to run. We're going to microservices. So the sheer number of instances we have to manage is getting a burden. We need a solution for that. And like Ray already said, containerization, Docker for instance, and orchestration, Kubernetes really helps in creating an environment in which you can manage a large number of operations. So I want to challenge you, Ray.
Yeah.
I brought some stuff with me.
Okay.
I created a small application containing some state. It's a CD database application, so you can enter your favorite artists, the albums you have produced, and the songs that are on that. So you can enter artists, tracks, and so on, and you can also delete and edit. So basically, it's got everything, and then you can store it. So how is that built up? Quite an easy architecture. We have a front end that's built in AngularJS that's being served by Nginx, a small HTTP server that's in a container. That's being backed by Java REST services, containing the logic, thread operations, and the data is stored. And I just use MySQL database. No fancy stuff, and I want to see that running on Kubernetes cluster.
Okay. Well,
So,
yeah.
before we get started, I want to make it more difficult for you.
Okay.
I want to have it. I want to see it running on a Redis micro.
Okay. All right. I see it.
So I brought my micro data set.
For microservices. Yeah.
Microservices. So it's more challenging. So we need to run Kubernetes.
Right. Oh, but you don't have to already. Thank you very much.
Yeah. I would be like Kubernetes are already running on the Redis micro, and that's all being set. But the Redis micro, if you want to build something yourself, there's a Kubernetes I wrote a nice blog I wrote. So if you have holidays coming, so or and really well. And we'll be seeing that. Now, let's dive into that. I want to see MySQL run.
Yeah. So remember, this is the beauty of Kubernetes. It runs in many, many different places. It's not something that's limited to the Google Cloud Platform, of course, although it's probably the best place for you to run it. But if you want to, you can also run it on Raspberry Pi, which, imagine, this is not a very powerful machine, but you can actually simulate the entire data center with similar components at a small scale and play with it. So let me do this deployment with MySQL, which actually has state. And typically, if you start a Docker container without a volume mount, that's not good for you to run MySQL. Why? Because when you start MySQL, it's going to write some data. When you shut it down, it's gone. When you start it again, it's going to start off fresh without any volumes, and you don't have any data. Anyone? Yeah, that could be a problem if you try to run a stateful application without keeping state. Yeah, great. So with the NFS mount, or if you are in your own data center, you can actually share different drives, different volumes in different ways, whether via NFS, iSCSI, RDB, Gluster, Ceph. There are so many different options, and many of them are actually supported within Kubernetes. And the first thing you need to do is to register the volume inside of Kubernetes. Okay? So even if you have that physical device available somewhere, you have to register it, because Kubernetes actually needs to know how much storage is being offered for this particular volume, which is in the capacity column right here. And the second thing is, how do you actually connect to the volume? How do you connect to it? So different type of shared file system has different way of connecting to it. In this case, we're using NFS, so I'm going to say the server and also the path. If you're using something else, like say Gluster FS, you'll do it differently, okay? And we can support many different ways. So the first thing I need to do is to register it. So I have created this thing, and I'm going to say kubectl create -f the volumes NFS volume YAML. And that is going to, oh, it already exists. Let me check get PV. No, okay, so let me delete that. So it's really easy to just delete the volume as well. So I can say delete PV. Yeah, let me do that. So I'm going to say delete the first one and also delete the second one. Okay, and now they're deleted, but the data is still there. It's just that they're not registered with Kubernetes anymore. I'm going to register it so that it will work properly for me. Okay, so I have created the volume here, and it has the capacity of 1 GB, and it is available. Now, the second thing I have to do is to lay down a claim, because all of these volumes are just resources to Kubernetes. And these resources could potentially be shared or reused, right? When the volume is actually being released, you don't want it to just sit there without being used if it's not important anymore. So you want to be able to reuse this, the disk with somebody else if they need the capacity. And so now what I need to do is I need to say, lay down a claim to say, I need to use the volume. Please give me one that best describes my need. And to do that, I need to create what we call a persistent value claim, a PVC. Okay, persistent value claim. And notice here, all I need to do is to describe how much capacity do I need. And the type of access I need to do, whether it's read-write from just a single container or a single pod, or is it the multiple read-write from multiple pods. So, but notice here, I'm not specifying which volume I want to use. I just say how much I need. Why? Because Kubernetes will then find the right volume that best fits my need and assign it to me. So if I need to lay down a claim and say, hey, I need to use a volume, then I need to create this PVC, I can do kubectl create -f MySQL PVC, and that's going to make the claim. And once I do that, if I do a get PVC, what I can see is that it's actually bound to one of the volumes that's available that best fits my need. And now MySQL PVC can access this volume. Now, then what I need to do is to update my deployment, okay, to make sure that I am mounting the right volumes. And that's really easy to do. All I need to do is to specify it. Say here, volumes is referencing to the PVC claim that I just created. Right, it's like a ticket for me to use the physical volume. And then I need to specify the mount path, which is here, that I need to mount this disk into var lib MySQL. Okay? And the beauty of it is that Kubernetes will actually take care of mounting this volume for you behind the scenes. So if I were to run this MySQL server, right, so create MySQL, service, and also the deployment. You all know what services are now. And if I do that, what this is going to do is, there we go. Let me refresh. What this is going to do is to run MySQL on one of these nodes. And before it starts the application, starts MySQL, it's going to mount that NFS volume for me as well. And then start the container, and then make sure that the volume is mounted into the path I specified. So now this MySQL server has the right data.
Okay. Yeah.
Oh, yes.
Yeah.
We have sound.
We have sound.
Yay.
So yeah, you can access it also.
Yeah, I can access it, but I can also access it directly by deploying the front end and the back end.
Okay.
Should we do that?
We'll. I want to see the backend running.
Yeah. So just remember, all of these things are running inside of the Raspberry Pi cluster. So I'm going to do something very quick because of the time. I'm going to just create f dot. What that's going to do is to deploy everything for me in one shot. Oh. Sorry, I think I used the wrong one. So now MySQL is actually deployed here. There we go. So now I have MySQL, the front end, and the back end. Okay. Now, when I created the front end, how do I get to it?
Yeah, we have the services running here on the Raspberry Pi, but normally the services uses an internal cluster IP address which can be used, but it can't be used outside of the cluster. So you want something to expose the service to the outside. In the Google Cloud, you have the load balancer for that. Ray already showed you. One easy thing to do that on this small micro data center is to use a node port. And what actually Kubernetes does when creating a service is dynamically assign a port number to each node for that service. So we have a certain port number at which we can reach that service within the cluster.
So in this particular case, it dynamically generated a port number for me. And so you can avoid all sorts of port conflicts if you are to run and share directly from the host, right? So it's on this port. So if I go there, all right, that works. Yeah, pretty good. So the application is up running. Can you see it?
There's already data.
Arjen's CDDB database. So he likes air. I don't know air, but yeah, there we go. And you can click into it. And then you can see all the tracks when it comes about, it's running on Raspberry Pi, so it's a little slow. But you can modify these things as well. So we have the full application running. Fantastic.
Okay, that's nice.
That's too easy. Yeah. Too easy. What else you got?
Well, our product owner just came, and we have a new version we have to ship. So marketing has decided that the coloring scheme was not that nice, so they offered a new styling. So we have a version 10 available for you, 10. And we wanted to roll that out into production.
Okay. So typically, what you may do is to deploy the new version and then shut down the old ones. But what I like to do is to do a rolling update for this. What I want Kubernetes to do for me is to roll out the new version one instance at a time or multiple instances at a time and shut down the old instance when the new instance is up and running. And you can do this very easily with Kubernetes too. And remember deployment, the box in blue? That can also manage the rolling update for me. So all I need to do is to do a kubectl edit the deployment. And I can say the CDDB front end. And then down here, I have the image that I can change. And if I want to update this to version number 9, I just update it. I save this file. Now, look, this is really cool. I'm looking inside the state of Kubernetes via my local text editor. And I can modify the state just by saving it. Now, as soon as I save it, what it's going to do is to perform a rolling update. And you can see the new instances coming up. And then once it's ready, it's going to shut down the older instances. And while all this is running, because we have readiness checks and liveness check set up in Kubernetes, you can actually just refresh the page, and it will still work during the rolling update. Yeah, did I use the wrong version? I think I did. But it's got a different color here. Yeah, it doesn't really work with the rest of the color scheme here. So I think we should probably.
Yeah, we have a problem now in production. So customers don't like the new color scheme. So we want to roll back.
Yeah. So
as fast as possible.
To do a rollback is really easy. I can actually see a history of my deployments as well. So I can do a kubectl rollout history, deployment, CDDB front end, and I can actually see a list of deployments I have made. Now, if I actually deploy this thing with a -- record, you can actually see what caused the change, what caused the new deployment. And you can roll back to any of the revisions that you see that's still in history, which is awesome. And of course, you don't keep all of the histories. There's a limited amount of that. But if I need to roll back, this is what I do. I can say roll out, undo, just to go back one deployment. And let me do that, and just say undo my deployment cddb frontend. And what this is going to do, check this out. It's going to do another rolling update as well. And now you're rolling back to your previous versions. Super simple to do. And again, because we have the health checks and readiness check, as we're doing this rolling update, all the connections will be routed to the instance that's ready to serve. Yeah, and now we just roll back. That's also too easy, Arjen. What else do you got for me?
I'm really curious. We have now our micro data center, and how many people are have been in a data center themselves?
Yeah, quite a few. Okay.
Quite a few, yeah. Anyone who wanted to pull a plug somewhere in the data center and see what happened?
Oh no!
Yeah. That's one.
There's one. I would love to do that too.
Yeah, you love to?
No, actually not here.
At Google?
No, I can't.
Yeah.
But I also don't want any plugs to be pulled today on this Raspberry Pi cluster, or is that what you want to do?
Yeah. So we had already a volunteer here. So come up on stage.
Woohoo! All right, give this gentleman a hand. Brave person trying to break my cluster.
And
wait, hold on a second. Why don't you swing back here? Swing to the side. Swing to the side so people can see this on video.
To make it really nice, I want to see the node going down on which MySQL is running.
Wait, you want to see MySQL go down?
Yeah.
No, come on, that
does happen in production.
That has happened before.
And in the past, I will be called that something is going wrong and it's in the middle of the night, and I don't want that.
You don't want that? Okay.
No.
So let me just show you that the MySQL server is up and running, as you saw in there. So I can do MySQL-p-host 10.0.0.120. Okay, and what is the password? Root. Yeah, of course.
Yeah. Everything is root.
It's not Superman, it's root. All right, so I can show databases, and we have the data here, blah. We have the Quintor database, which has Arjen's favorite zones. And it is running on 04, so it's running on the fourth node.
The fourth node.
Yeah, whatever you do not plug the first one. It's the fourth one.
The bottom one. This one.
Yeah, there we go. Are you ready for this?
Yeah. Oh, yeah.
All right, so it's gone. It's gone.
And now?
And nothing happened. No, just kidding. So what Kubernetes has been configured to do is to check the health of the machines as well, and we configure it to check every 30 seconds or so. So in about 30 seconds, which is right about now, if it ever works, you're going to see node 4 turn red.
Yeah,
turning red. Yeah, there we go. Yeah. Wait, that's too easy. That's too easy. Of course it turned red. It went down. But look,
and what's happening now?
Check it out. It actually restarted MySQL for me as well. Yeah, it's not bad. MySQL is now up and running. Yeah, very good. And actually, this is what Kubernetes actually do behind the scenes. Remember the volume mount? Well, the volume is no longer just mounted on the machine that died because it went away. Kubernetes managed the volume mounts for you. So now, if I go into that node, SSH into root at 10.150.4, oh boy, .3. By the way, I get really nervous about this demo because unplugging MySQL is not something that you should be doing. I do not recommend trying this at home. But if I were to go back here, definitely don't do it. Wait, what? Oh yeah, sorry. It's 0.4.4, isn't it? Yeah, that's the name. Oh, sorry. 4 is gone, so it's on 3 now. Yeah, so if I go there, check this out. This is really cool. If I can connect to it. There we go. If I go root, yes. If I do, if I show you mount, if I see NFS mount, it's actually here. So that's a good sign. The other thing I want to make sure is that I can actually connect to it. Now remember, MySQL just got rescheduled to a different machine, but I'm going to use the same command line to connect to it with the same IP address because it is using a stable IP. It's exposed as a service. Now if I go to root, it connects. That's not bad so far.
Is the database still there?
Yeah. Oh, is the database still there? Let me see. So not used, so show databases. Yes, it is still there. But do we have the right data? Are we cheating? Do we have the right data?
Different volume, yeah.
There we go. So I just refresh my application. And as you can see, it's connected back to this right database because I have to retry, reconnect. So it reconnected. And we got all the same data here. So yeah, very good. I guess that worked. Thank you very much.
So thanks for our real-life chaos monkey.
Yeah. And if you plug it back in, then it will be marked as scheduled to be ready to redeploy as well.
Well, we have the application now running on my micro data center. Really nice. But we can't go into production with that.
Yeah, if you don't want to use Raspberry Pi, sure. But if you want to run it on-prem with a more powerful machine, you can. But we can also run it on Google Cloud as well, like I showed earlier.
Yeah.
And the beauty of it here is that if you want to achieve a state where you want to not only be able to manage your services efficiently, just like what we have shown, but you also want to have a hybrid deployment across multiple data centers or multiple different providers, whether it's cloud or on-prem, you can actually use the same set of descriptors. Like here, this is running locally on my machine. I have the same deployment YAML files, which is nice because you can check in your architecture. The only different thing I'm doing here is the volume mount. Why? Because in the cloud, rather than using NFS, I can actually mount a real disk from the cloud, right? I can provision a new disk, I can mount it. So all I have to do is to provision that volume, register it with a different persistent volume. And here I'm just saying that I want to use a GCE disk. And so I can go ahead and create that. And so I can register it. And then I can go ahead and lay down the claim. So I can do the MySQL PVC, right? And once I have done that, by the way, this is all happening in the cloud now. And what I can do finally is to deploy this application. I can just do a create dot. And there's one very big difference here, which is in terms of the load balancer. Because rather than exposing on the node ports directly on each individual machine, I can actually instruct it to create a real load balancer directly from the YAML file as well. And now the application is being deployed. Let me just go back and take a look. The same application, the only thing that I really had to do was to make sure that, well, of course, the ARM binaries don't work in the x86 environment. So I had to change the base image so that rather than using an ARM's Java binary, I'm using an x86 Java binary. And once this is up and running, we can actually go and see it. Now, what this is doing right now is just waiting for the external load balancer to be created. So if I say get service, what this is going to do is to create a real load balancer with a real external IP address. And there we go. So that's the external IP address. And I can go there. This is too hard. And there we go. We have the same application deployed in the cloud with the same descriptors. It's very easy to do. So all of a sudden, you can just deploy to multiple environments with exactly the same way. And that's beautiful.
Yeah. It's really nice. You have one set of configuration files, and you use it for different environments to do that. So to set them up. So that's really nice. So
yeah. So if you're interested in this technology, please give it a try. If you want to learn more about Kubernetes, go to kubernetes.io. And if you want to try Google Cloud Platform, you can go to cloud.google.com as well. And you can provision Kubernetes clusters very, very easily by a click of a button. We'll install everything for you and manage everything for you as well. If you want to try it on the Raspberry Pi cluster, check with Arjen. We have a really, really good blog that he wrote. So you can buy the right components and play with this as well. So thank you very much for your time.
Thank you.
All right, thank you very much.
Yeah. Do we have time for questions?
There's no time for questions, but there are very interesting questions, so we will make some time for questions.
Okay. All right. Nice.
Before anyone decides not to wait for the questions and leave, please vote. I see that we have massively enjoyed this presentation, but also see that the actual head count is much higher than the number of votes. So please vote for this session.
Thank you. Yeah.
There's many questions, and we can't handle them all. But since you're a Google guy, here's an interesting one.
Oh, no.
How well does Kubernetes fit Amazon Web Services?
How well does it work? Or it actually works. In fact, in one of the conferences that I've been to about more than half a year ago, one of the attendees came over during lunchtime and said, this is so awesome, I want to show my boss how to do this. I'm like, yeah, sure, let me deploy this. Are you using cloud? Yes. No. So what do you need to deploy this on Amazon? So, but you can actually do it. Over lunchtime, with the right tool set up, downloading the right services, it actually just installs, and you can provision service there as well. And it actually works with their load balancers and their disks as well. So you can give it a try. But if you're running on Google Cloud Platform, of course, we also have really good support with a click a button with a single command line. You can also provision the services for you. Yeah.
All right, last question. What's your experience with database performance when running on NFS volumes?
That's a great question.
On Raspberry
and
Pis.
You probably should not do it. Now, just remember that NFS is something that we're using for the demo. Some people still use it for variable of things. But if you want to use something faster, you can. You can use RDB, iSCSI, and a bunch of other things as well. Yeah.
All right, great.
Well, thank you very much.
Thank you.
Yeah.
That's it. Thank you very much.
All right, thank you.